All right, guys, welcome back. We are Game 3004 in the winter 2022 semester at George Brown, and it's week 10, part one of our broadcast. We're going to do another one on Thursday. So for today, what we're talking about is VFX graph. And let's get into that. I think it's exciting. All right, so let's get into this. Again, we're sitting at kind of the bottom part of our project. You guys have just submitted your alpha release this weekend, just passed, and now we're into the final few releases. The one that we'll worry about next is the beta release, which is due week 12. And all things being equal, it'll be due week 12, okay? All things being equal. So that's the one you should be working on right now. We're, again, sitting on the week of March 14th. Today is the 15th officially, but we're doing VFX graph, particle effects, and some 3D explosions this week. And how can we do that? How can we make them work on mobile? Is it plausible? We'll talk about weaknesses and things that can work out for us and that kind of stuff. So last week what we did was we converted our project to mobile, which was a bit of a jump. Some people were able to do it, no problem. Other people had issues. We also, kind of put together a very basic loading and saving game system. Game state, we talked about player preferences and binary formatter. And, there's other things we can talk about that today. In lecture, we also talked about the Quest system idea. This week, what we're doing is, from a components perspective, your 7th weekly report is due on Friday, so please make sure you get that done. People are missing some of this stuff. Your beta release is due week 12. Lab 6, which is all around VFX graph, is due on Saturday. That's going to stick regardless of what happens on Friday. 8th weekly report is due next week, okay? And this week, I haven't got much in here yet because what we want to do is I'm going to define a series of custom effects that I'm going to get you guys to do. And I want you guys to layer 2 of them together, right? To create your own effects, okay? Your own effect that you're going to be able to use on mobile. It has to work on mobile, and you have to demonstrate it inside of LD Player. We'll talk about the stuff that's possible, and we'll talk about the things that are not possible. So that's the lab, and I'll give you more details around that on Thursday, okay? So today we're going to talk about it, and then we're going to try and install part of it, and then we'll see how that goes. All right, so visual effect graph. Right, what the heck is it, and why not just use a particle system, right? So the 8th report is due this Friday. Let's fix that, Mandeep. That should not be the case. So that is the weekly report. Yeah, 8th report is due Friday, that's right, and the 9th report is due on week 11. Did I say the wrong things? Yes. Love it. 8th report is due Friday, and 9th weekly report is due next week. There we go. Thank you, Mandeep. Just the numbering was off. That's all. Not sure what happened there. So what is it? This is a Unity package. No problem. That we can use for different visual effects. And there's a reason why we're talking about it here, even with mobile, compared to the stuff that's out there right now. The visual effect graph, what it does is it works on the GPU, and it's able to simulate lots more particles than in the built-in particle system. So that's the major advantage to it. And now, especially with most of our modern phones having some kind of processing power, I'm not going to say it has a discrete GPU, but it does have, a lot of the newer phones have compute capabilities, especially onwards from the iPhone, if I'm not wrong, if I was looking at the iPhone models 11 and forward, and generally the newer Android models, all of them have the ability to give you compute shaders and that kind of stuff. They all support Vulkan, and the great thing about that is that means that they support you doing visual effects on the GPU component, even though it's not a discrete GPU on your phone, and it's usually combined or connected to your CPU in some way. It definitely offloads some of the load when it comes to particle effects. You can make things look awesome, as an example, on your phone with by using the visual effects graph. So that's the thing. Now, I have to be honest, this will push the limits of what we can do on our mobile devices, right? And there's some work we have to do to establish this stuff. And the reason why I wanted to bring this up right now is because we have to also install URP at the same time. So that's something that we have to do today. We're going to try and install URP. And the first thing we do is install URP, make sure it works and everything else. And then from there, once we've made URP work with, we can transfer or translate all the shaders that we have right now, which are typically standard shaders. We have to, kind of connect them to URP compatible shaders. And we'll try it in a couple of different ways. So that's Visual Effects Graph in a nutshell. It uses basically, it creates particle effects on the GPU, okay? And it's also visual, which means instead of you doing particle systems, as an example, with that one particle system component, what we're going to be doing is we're going to be using visual scripting to create particle systems. We'll do the same thing with shader graph. So visual effects graph, shader graph are the two things that we can use once we have URP installed, as well as everything else that comes with URP. So we'll talk about that in a bit. So some requirements. So Visual Effects Graph supports URP from Unity 2019.3. That's the most important piece, right? It doesn't support every feature, right, that HDRP supports. Note, URP, does not support the gamma color space. So if you have gamma color space turned on in your settings, it just won't work, number one. The other thing that we also have to talk about is the fact that HDRP, don't try and run HDRP on your phone. It will not run. Okay, it won't work. URP is the most you can hope for right now in the current build that we have right now. The other thing is that OpenGLES, right, is not suitable for VFX Graph, and we have to use Vulkan when targeting Android. Okay, so that's important as well. So far, I've turned Vulkan off, and we've been using OpenGLES, but now we get to turn Vulkan on, and we're going to see how that has an effect on our simulator. Does it even work? Well, we're going to talk about that too. Okay. So what's new in version 12? Because right now, and this will be different than what we did this time last year, because we talked about some other things. But in version 12, VFX Graph, what it does is it adds support for lit outputs. So that means you can use the lighting in the scene, to get additional effect that's added on to your objects that are in the scene, which is pretty cool. It has a lot of other things like 2D render support for compute capable devices. Again, you're going to need something like that anyway to run this thing. Bounds helpers for screen bounds, as well as graphics buffer support and sign distance field baker, which is something that's all built in. This is all the new stuff that is available for us with 2021.2, 2021.2. Whatever X editor that we have right now that we're running. So how do we do it? Well, we need to, it uses compute shaders. So this is the most important part. If your phone does not support compute shaders, then it won't support VFX Graph, no matter how we create it, which means it makes some of the stuff that we're going to be talking about incompatible with previous versions of, or older phones. Like if you have an older phone, it's just not going to work, all right, because it just doesn't have the horsepower, and it doesn't support compute shaders. It's not going to have it. And if you look up, just as an example, if you look up Android phones that support compute shaders, right? There's a list, right? So, and one thing that you have to go do is, how did I look this up last time? So, basically what it is there's just a bunch of phones that will do it, but there's not, it doesn't support a lot of them. Okay. So that's number one. So let's do it. Let's get into that. We'll start off with this first half. This half, we're going to start doing the conversion, and that's part of your lab for this week. This week's lab is let's convert our project to to URP. So first, let's convert our project, the one that we've been playing with around, to URP. That's the first step. Let's do that now. Okay, and let's get into that. So And again, we have to work together on this, guys. And I want to make sure that we're all on the same page. So up on our desktop, we have some examples. So here it is. And again, I have both sections here, but it doesn't really matter. What I'm going to do, because we're starting with Unity, I'm going to start off with one of them. Typically, we start off with section 400. I'll do the same thing on the other section as well, and I'll put it up. So let's just move with Lab 6. So again, I'm going to make a brand new folder. We'll call this GAME3004 Winter 2022 Lab 6. And we'll just copy everything from the previous folder, right? Ha ha ha. Don't ship with your game. It's the backup for this folder. Delete. So what we want is to grab everything here other than builds and library. We don't want builds and library. Copy that over and into your Lab 6. And what I'll do is for you guys who are watching, who are in different sections, for Thursday's class, I'll have this thing done exactly the same for the other section, okay? So now that I have that, I'm going to open it up. So let's do that. So again, section 400 first, Lab 6. But it doesn't matter even if you're section 401, which is like the people in the afternoon section, it's totally fine. And Unity is going to do its dance and load up the stuff that we need. So please be doing this at the same time as me, guys. Now the intent today is to load URP, make sure URP is configured properly, so Universal Render Pipeline, which is required. And this PowerPoint has some of that requirement right here. So when it comes to, so why VFX graph, while you're looking at it, again, typically particle systems use CPU, so that's where it's done. And it uses the underlying physics system for this to happen, right? And we have maybe thousands of particles that we can show at one time. So pretty good effect, looks pretty nice, and so on. But where VFX graph, it doesn't just do thousands, it does millions of particles. So millions of particles on the screen at the same time. The simulation is complex. The physics, it doesn't use the underlying physics system. It uses primitives, the depth buffer, other scene representation, and so on. So that's one thing. One thing that that Visual Effects Graph can do, it can read frame buffers, right, which is pretty cool. So things like once we have a frame buffer object or FBO, you know how that works. We can do things like deferred rendering. We can do other things like on the GPU that we normally don't do. Normally we use the forward renderer, especially on things like mobile phones, right? We don't use deferred rendering. It requires more of a discrete GPU to have that kind of power. But with some phones that have compute shaders enabled, right, and so or compute shader support, then it's amazing what it can do. So again, the newer phones, I'm thinking iPhones after iPhone 11, and most of the modern Android devices that have been released, Google Pixel and so on, all those kinds of phones, they're going to support compute shaders, no problem. Okay. Let's see if we're almost done. We are. So here we are. We're in this thing. And what I want to do immediately is go into my main scene, right? We have our scene the way it is right now. I'm going to move into from this, right, as an example. One thing I'd like to do is move just into the, instead of the simulator, I'm going to go into the game for a second. And 1024 by 768 doesn't cut it. What I want is a landscape of 3040 by 1440, so it looks very similar to what we've seen before, okay? In the past, one thing we've also done is we've done platform detection with the application.platform settings, and I think this is a good thing to put in so we can use all of our fallback functions before we get started. So let's open up our scripts, is what I mean. And let's get into that camera controller that we had before. Remember the camera controller, what we did was we disabled things like the lock and all that kind of stuff. I want to prepare before we move into URP. Let's get that done. So notice that the cursor lock state has been disabled. And the reason for that is because our application platform, so we can check for that. We can say if, and this is kind of like a side effect of what we're trying to do, because we want to have some control here, right, to test things out. If my application, come on. I love ReSharper and I hate ReSharper. My application dash dot, come on, platform, right? If it's not equal to platform Android, so if it's anything else other than platform Android, what I want is to turn on this cursor lock state, right? So that we can actually use the mouse and everything else we had before. So let's turn that back on, okay? Otherwise, that cursor lock state will be off. Okay, so that's the first thing. So we're using application detection or platform detection, just like we did last semester, okay? Again, another way to do platform detection is to use the preprocessor commands to do that. I prefer to do it this way, but you can do it whichever way you like. Let's also do the same thing for our mouse and our joystick support. So what I want to do here is I want to say that if, application.platform is not equal to runtime Android, right, this one. If it's not this, then I definitely want to turn on this piece, right? So let's put that back in there. And instead of, well, we won't call it mouse. We've already started calling it horizontal and vertical. So before I even uncomment these things, I'm just going to change those, that up. I also want to put the float horizontal and float vertical up here, just so that way we can establish those first, float horizontal and float vertical. Okay, that's what goes there. And this way I don't have to declare it down here. Okay, so let's just turn those off. And what we're going to basically say is, look, you know what? If I'm not Android, then use the mouse. If I am Android, then don't use the mouse, which is this part. This is the right joystick. So this will give me, kind of control, as an example, over my my camera without using the on-screen controls. So that's what this does. So if we want to test this piece, again, this is nothing new. It's exactly what we did last time, last semester. Okay, exactly the same. And if you don't remember, it's okay. But if you go back and if I rerun this application as is, and I'm running it in landscape mode in game, not in simulator, then what we should get is, without clicking onto the control itself, I should be able to move my camera around and no problem again. Yes, that's the one thing to do. And notice that I can't do this piece because I'm not on that platform anymore, right? So, because I'm in the editor. The other thing I want to do is disable all these on-screen controls. So we already have the on-screen controls kind of put together. Last time we put it in a canvas inside of a on-screen controls, kind of a parent game object, which we can just turn off. We can turn all these off when we don't need them. And I want to use platform detection to turn them off when we're not on Android, okay? Because that's all we care about right now. Clearly, if we were going to be on a mobile platform and if we want to support iOS, it would be either Android or iOS. But here we're only supporting Android for this course. So that's fine. So let's get into the player behavior. All right, so here's player behavior. We already have access to my on-screen controls, which we had before. And what we're going to do is in my start, I don't want to do this more than once. I'm going to go here and say same thing as we did before. So I'm going to say application.platform, right? If my application platform is not equal to Android, then just like we did before, we're going to turn off those on-screen controls. So we're going to say that on-screen controls, and we're going to, set active to false. Okay, that's what we're going to do. If we don't have, if it's not Android. If it's Android, we're going to put them back on. They're going to be shown, okay? But there's some stuff we also need to do down here, right? So if the controls are not on, we don't have our save and load functions available. We do have on map button pressed. We also do have on jump button pressed. and we don't have a map button that we get. We can't turn our map on with keys. Let's put that key support in here. So we'll say something like if input.get key down, right? And we'll have a key code, which is M for map. Let's just suppose. Then we can turn our map on by saying something like our minimap dot set active is equal to not minimap. We'll just do the same toggle that we did before, active in hierarchy. So same kind of toggle that we did down in here, right? With our minimap, we'll do the same toggle over here with a key down, and key down only works once. All right, so let's try this out now. We're almost there. We just need to do saving and loading, and we're good to go with all of our on-screen controls. That's a very quick hit in terms of the things that we wanted to do. Save, go back here, and when we run this thing, now all of these controls should disappear. Let's run it. So again, now we're back to normal in terms of some controls. We can run around, do the same thing we did before. We can even turn our map on and off with our M button, which is pretty cool, okay? So again, that's fallback for what we did before. Okay, and again, going back to this, in terms of the things that we want to accomplish today, is, kind of use platform detection to remove on-screen controls, right? And we want to provide keyboard input for additional functions. Example map, saving and loading. Okay, that's what we want. So let's get back into the one thing we're missing is saving and loading. And remember that happens in our game controller. We have this game save manager that we use. So if I pull up my game save manager, then right now we're using binary formatter to save everything. Oh, one note about binary formatter that we talked about some improvements. Remember that we also have, for binary formatter, we have this little class called save data, and we have our public float player X, Y, and Z, right? And I think for the other class, I also did, we also saved our rotation as well. So if you ever wanted to save everything in one, you don't have to do X, Y, and Z, but instead we can do an array of floats. So let's think about an array of floats. If you guys have something different than this, then you can just watch. But let's suppose I have a float array called position, right? So that's like player position, we'll call this. Player dot or player position. And if we're going to do something like this, a float array for saving data instead of individual floats, which makes more sense, then we might as well do a public float array, right, for player rotational data, right, which is something that we want. And I think I kind of did this in the last class. Correct me if I'm wrong. Which means that when it comes to serializing our data, then what I want to do is, because our player position and our player rotation, again, in our saved data, we have a number of ways we can do this, right? One thing we need to remember is we need to instantiate an object of type float array. So we can do that inside of a save data. We can do this inside of a save data constructor for our save data class, where I can do something like, hey, player position is equal to a new array, empty array, as an example. And the new, and this is kind of initializer syntax. We know it's going to be a, an array of 3 floats, because 3 floats are going to signify the vector, okay, that we want to save. And we can do the same thing with player rotation. We just can instantiate, these are just empty containers, right? Empty float array container. That's what we would, just like we would if we were going to do an empty float list or whatever we want to do, right? So now that we've done those things, and that's going to trigger every time we call, we create a save data object, which is right here. You can see that that's going to be done, right? We also have to make this constructor function public, and in C#, you need to specify whether it's public or private. It's not public by default, right, for constructors, okay? Then down in here where we have data, the player data, then it would be looking different than this. What we can do is we can use initializer syntax, right, where we can say something like our player position, data.player position is equal to a new array, and we can put in the player position data where we can say the player.position.x, the player.position.y, and the player.position.z. So that is totally fine. And we can use initializer syntax to do just that. Even though we've instantiated this stuff up here, this is a safeguard. Unity won't complain as much when we create a new object that's empty. We have two empty objects, and it'll cut down on some of these issues, right? So that's why we're doing it this way. Not because we need to, because this is sufficient, right, to compensate for this. And this is more dynamic, but it's going to overwrite these things anyway. All right, that's number one. And then the player, this is where the things are a little different. When I want to do the player rotation, let's say, for example, I want to save the player rotation as well. So this is an extension of what we did last time, player rotation. Then we can't just send off player rotation data like so. We can't do that. That's not sufficient. Why is this not sufficient, guys? Why can't I just save player rotation X, Y, and Z? Well, you can't, yes. So you got to do something like dot, and notice that
rotation's a quaternion, right?
Correct. So it's rotation and then Euler angles. That's what you have to do. Rotation Euler angles dot x. You just got to fit in Euler angles in there. So rotation Euler angles dot is what you want to put in there instead of just a dot. Okay, so just make sure you put those in there and you're good to go. Right? Rotation Euler angles, we want to save that because saving it as quaternion, and we don't want that to, we want to convert the quaternion into a vector 3 object that contains 3 floats, which is totally fine. So that's how we serialize. At the same time, when we pull information from the binary formatter, the changes are the same on the way back out. So we can say X, Y, and Z, and that's fine. But what we want to do is we want to say that it's the data dot the player position, dot, and we can say dot X, Y, and Z. We can do that. But we know also that we can instantiate new objects of type vector 3. So we can just say like var player position, just to save us. Instead of var, we can say that that's a vector 3. That's what it is, right? We can do that all together. And we can say that that is equal to a new vector 3 object with our player. So our data dot player position dot x dot data dot player position dot y and our data dot player position dot z. And that should be
player position is an array.
Sorry, I'll be okay. I'll be okay. I'll be okay. You're right. It should be 0, 1, 2. Yes, yes, yes. I'll be okay. Thank you. Great thing about this is that it's good because this is how it should be if we do this. And the reason why I'm showing you arrays is because that is more efficient than just something like this. That's not efficient. And when we want to do the same thing, for our player rotation. But the problem with the player rotation, because it's not a vector 3, it's a quaternion, right? That's what we want to get out of it. And we can't do a vector 3. It's a new quaternion Euler. So it's a quaternion dot Euler, right? Where we pass in the X, Y, and Z position of the object. So instead of now why is this not doing what it's supposed to do? Ambiguous reference, system numerics quaternion. Why? Visual scripting. Isn't that funny that it included visual scripting by accident? And it also did this vector 3 crap, which it shouldn't do. That's just for me. That's my bad, right? So really Unity engine is what we're doing here, and vector 3 is that is really strange-o-matic that it's doing that. But anyway, we'll get back to this. We'll fix this. So yeah, so we can't do player rotation dot whatever without without using the quaternion Euler thing. So I'm just going to fix my problem in a second. That is just a reference thing. So Unity engine is there. And I think I got to do, because I'm using vector 3s, and it's mono behavior though. Game save manager is mono behavior. So what did I do wrong? A vector 3, well, let's call it, make it a var. That'll take care of that part. But a vector 3, that is so très bizarre. Yeah, so first we get our player position and player rotation, and we want our player dot position to be the player position. And we want our player dot rotation, which is a quaternion, to be the player rotation. That's what we want. But why, oh why, oh why? Do I? No, I knew there was something wrong. All right, so it was just a reference, and that's why it was ambiguous. Okay, so that idea is, I think, far better than, I mean, again, you could also do this in one. So instead of making these variables, you could do something that looks like this if you don't want to do that, which is nothing wrong with that because it kind of kills two variables as well. And we always want to try and save any kind of memory allocation all the time. So kind of the final version would be looking something like this. Are you in agreement? Do you agree? What do you think? Yeah, so I think this is good. Yes, Vince, is that your hand, or did you leave that up from before?
It's up from before. I was just a little bit behind because I was something wrong with my camera controller, not checking the platform properly. But I having your live recording on the side as well, just in case I missed something.
Okay. So that's how it goes. So this is our new version of our binary formatter. We say position and rotation, not just position. And the great thing about this is if you've never seen this kind of syntax before, or if it's been a long time since you've seen it, it's neat because C# supports this kind of stuff, which is very JavaScript-like, actually. This is kind of what JavaScript supports, and C++ too, right? This is what we can do with C++. So kind of that initializer syntax, which is great because we want to allocate objects to the array, as an example, instead of doing individual objects. It saves us a bunch of lines of code. All right, so this is great that we've done this. And now let's get to that URP part that I talked about. First things first, though, we need a couple of keys. Oops, I forgot that. Let's go back to that. We need a couple of keystrokes. So inside of our, we have save data, we have our transform, and we have our save game, but we don't have a start or an update. Let's put an update function back in inside of our game save manager, where I'm going to say if input.getKeyDown, just like we've done before, get key down. And we're going to use our keycode.k for the save. So we'll say this will be the save game for keycode.k. And we'll also use the same thing for our load game. We'll just use keycode.l for the load game. Again, if you don't like k, it's okay. I'm using k because that just makes more sense to me because it's right next to the L. You may choose to use another thing altogether. But I'm just using a couple of key codes so that way we can test to see if it loads and saves, and if it saves our position. All right, now that we've got our key codes and we've got our fallback support for all this stuff, the things that we did differently, let's try it out and see how it works. So again, we should be able to run this. And why am I doing this? Because I want to be able to support URP, check out URP, and all that kind of stuff without any kind of issues. Let's do that. So then I can run around, right? Let's say we can go up here. And that's what happens if we're up here and I'm looking over here. Can I save everything? So it's going to be K to save, right? And L to load. So K, saved, right? And then let's stop that. And let's see if we get back up there. So we run it again. And if we do it again, and we press the L button, then boom, right? Now that's interesting. I'm looking down and it should be looking up. How come? That's the only thing that's different. So just to note that that is the case, okay? So not exactly perfect, but it's not bad in terms of where it takes us. So it does save and load, and that means it's pretty good in terms of a functionality. Okay, now that we've got that, let's load the URP and see if we can break this thing finally, right? Because this will break you sometimes. Camera angle is missing. Did we do that? Yeah, we didn't. We didn't care about the camera angle, did we? Because the camera angle is, we didn't save the camera angle. We just saved the position where the player is looking, not the camera angle. You're right, correct. Camera is not something that we care about. That's right. All right, so that's fine. We can put that back later on. For now, one thing to note also when it comes to this is how do we convert the URP? Well, we're going to go to Window. We're going to go to Package Manager. I'm sorry for the sprint here, guys. Like I am sprinting to get this done. And notice that we don't have URP in our package because we're using mobile packages. Okay, so this is the risk that we're going to take. We're going to go to Unity Registry. And under the Unity Registry, we're going to scroll all the way down to where it says the Universal Render Pipeline, which is right here. Now notice our version is 12.1.2. 12.1.2, that's what you should have here. Okay. If you have any other version, there's something wrong with your, your version of the code, because you should have this too. I'm going to click Install. Okay, this is going to take a bit of time to do. And again, Universal Render Pipeline it works. We save the player rotation events, but not the camera. The camera is a separate object that's in the player itself. So even though we're looking, our player is turned to a certain thing. The camera is a totally another object that's part of the player cam that we didn't save at all. So that's absolutely correct. We didn't care. We didn't think about that. Again, if that's not important to you. So the one thing we want to do is once we've installed URP, I would say caution on installing samples. Caution. So where it says, hey, there's some samples here you can try out, guys, be cautious. Okay. A lot of times samples fail, to work, and they cause errors because they come with additional scripts that you may not want. So be cautious with this. Worst case scenario, if you do install them and they fail, just remove them. But you need to do this, and it needs to be put in properly. Okay, so now we have our URP installed. I'm not sure if yours installed as fast as mine. Hopefully it did. And I'm not even going to try, shader graph or visual effects graph, which is the next thing we're going to do. VFX graph is right here. Notice that is not installed right now. We don't want to install this before we make sure that we have our URP working properly. Okay, so just because we installed URP doesn't mean everything is working. That's not what's happening here. This is where all the meat comes into right here. Let's talk about it. So first of all, when we look at our edit project settings, this is the first thing we want to look at. We bring our project settings over, you can see that the scriptable render pipeline settings, we're using nothing. And if I click on there, there's nothing to use, right? That's inside of my project settings graphics. So that is definitely something we can do. Now, one way to do it is to go into graphics, URP global settings, and then click this new button, okay? And this is kind of a thing we want to do. So if we click, so again, I'm in project settings, please join me, right? And I go in here to graphics, right, as an example, and then underneath graphics, there's if you open it up, so if you expand it, there's this URP global settings option. And notice that the non-universal render pipeline global settings, there's none, all right? So notice it says that there is a fix. Select the URP global settings asset. We can click fix, or we can click new. If I click new, what that's going to do is it's going to say, well, what do you want? It'll give me this universal render pipeline global settings asset, all right, that will include here. Under graphics, now notice that I still can't grab anything. So URP global settings is one thing we want, okay? And it says project graphics settings do not refer to a URP asset. Check the settings graphics scriptable render pipeline settings, quality render pipeline asset for which one you want to render. Because even though we've added URP global settings, we have not changed the graphics rendering. It's still using the old rendering pipeline. Nope. So there's nothing in here right now. Next, what we want to do is let's skip out of this for a second. And let's notice that down here, this is global settings. That's what these are, global settings. Okay, so there's this one, and I think I made it twice by accident. Let me just remove one. And again, just to confirm, you should only have one of those. So you should only have one of these active, not two. I just clicked it twice by accident. What we want to do is we want to add and again, you can put it inside of a spot inside of your assets. I recommend something like render pipeline as a new folder.
Sir, if I may, quick question.
Yeah.
Does it have to be URP? Can we use, for instance, HDRP?
No, you cannot. It has to be URP. If you're using HDRP, it will not work on a phone. All right, so render pipeline is there, and then what you need to do is you need to go into, and we want to do this because one of the challenges are you can right-click. So there's a couple ways to do this. You can right-click, and what we want to do is we want to make a new asset for a rendering pipeline, right? And because right now, we don't have a rendering pipeline asset, right? Just to let you know, we don't have one. We're using the old rendering pipeline. Okay, so that's the thing. So if you go to rendering at the bottom, so again, show you that again. So right click, and if you go down to create, and way at the bottom, there's something called rendering. This is one way to do it. And notice that there is a URP asset with 2D renderer or URP asset with universal renderer, right? So this is the one you want. It's not supported yet. That's what it is. So this one is what you want here. URP asset with universal renderer, this one. Okay. So once we click on that, it's going to make a brand new asset and just leave it. I don't care about the regular name. I'm totally fine with using the new universal render pipeline asset. I don't care about that. You can make it your own if you want to. I'm just leaving them as is. Once you've created the new universal render pipelining asset, this one, okay, it also points to a couple things here, right? Then each one of these things, right? It says the null reference object reference not central initial, which it says that the library reference, from a transparency pass perspective, because it's not really being used, that's fine. What you can do is you can go to edit and you can go to your project settings again. This is where we can mess things up. So remember, we can always go back. We don't have to use this URP, but it's required for VFX graph. Then we need to go into where it says graphics, and then we can select it. So this is the most important piece, which we select the new universal render pipeline asset. Once we've done this, just warning, once we've done this, it changes everything, and our entire assets stop working. It looks like this now. Yeah. Are you with me? And actually, if you run things, it'll still run. It'll still run, but everything is going to be, the entire world is going to be purple, which kind of looks neat. Even the coins and everything, they'll be all purple and they'll look like this. So it's not the mats, it's the textures that you have to use. So the mats have to be changed, right? All the materials, all of these materials, the base material, the black material, the bronze material, all these things. We'll start with the gravel cobble material, the ground material first. And notice on the top here where it says standard, we can't use a standard material. We need to use a universal render pipeline. It has to be universal render pipeline. And notice that there are some options. We want to use a lit material, right? And there's lit and simple lit, complex lit. There's a bunch of different ones. And there's also Autodesk Interactive when we need it. We're just going to go for lit, right, as an example. And you can see that if everything goes well, then if we look at the asset, so if I go back to the tile assets, one thing that we're missing is the textures now are missing, right? So once we've switched from one thing to the other thing, right, the gravel cobble ground texture is something that we need to put back, right? So notice that it says the base map, the metallic map for surface inputs, normal map, and all that stuff. Well, the base map is just going to be this thing. So you need to, kind of drag and drop this so we can actually see it again. Yes, every single texture, right, when we do that, right? So again, if you had a gravel cobble normal map, cobble normal, if you want to do that, I'm not going to do that here. It's going to waste time, but you could. next you want to do the concrete material as well. So materials, and here's our concrete material, which is the standard material. We just want to change this to a universal render pipeline material and go with a lit material, right? So that kind of brings it out. Now, notice the difference in materials altogether. It's much brighter and better. A lot of the way the universal render pipeline looks is just a lot nicer than what we had before. There's no tool. Okay. Well, there is a tool, but I recommend not to use it. Don't do that. There's a conversion where you can kind of go through and you can convert everything in one blow. I think if I'm not, where you can convert all your stuff over to forget where it is now. There is what you can do is you can convert everything.
I think that's an edit, sir.
Yeah, I'm pretty sure you're right. I don't recommend it though, because sometimes what ends up happening is it will
rendering.
Yeah, and then generate shader includes. The problem with it is that even if you were to do that, I'm not sure if that was the one that you were referring to, the generate shader includes. I personally don't prefer that at all. I recommend you go through and make sure that everything is correct. So all your materials. So notice the base material now is still standard, even though I did that. So let's change that to a universal render pipeline material. Lit.
Oh, sir, for this part, can you also like go through the materials and like control click it or shift click it and change them all at once?
Yes, but again, some materials aren't the same. So obviously our black and our bronze, look how they're different. Bronze is Autodesk Interactive, and black is just regular black. So that's the problem, and that's where I'm more cautious to do it that way. So bronze has albedo, metallic, roughness, and a normal. We may lose this mapping, just letting you know, when we switch to universal render pipeline, Autodesk Interactive, right? We may lose that, okay? Just letting you know when we do that. It may happen, right? So that's the bronze material. The coin material, again, same thing. We want to go to the universal render pipeline, Autodesk Interactive material. And now notice that what happened was, even when we did that, it said that we should use the color map for each of these things, okay? So we need to do that. And if we don't, then what ends up happening is it won't look right. Concrete material's done, which is pretty cool. Death plane material is not done. We have to change them all, even the ones we can't see, guys. Doesn't matter. Just change them. Enemy marker. Now, okay, so let's see what happens with the enemy markers. Do we have to change those or not, right? And so you can see that the material looks pretty good still. All right, it's all right. This one is not complete. We didn't finish that off yet, okay? But that looks okay. What about our mini map? That also is going to be an issue, right? Because we have a lot of stuff that we had in the mini map is going to be changed. It looks very different than what we had before, okay? So, but if you notice one more thing with the mini map, is that the player markers are okay, okay? That's important to note. Player markers work. So we don't have to change these player markers, even though the enemy marker and the player marker are there. You can see that we can still see them here, and so they're okay. Gravel cobble's okay. Again, just be aware of how that works. The metal material is not okay. It's an Autodesk Interactive. We're gonna have to change that back to Autodesk Interactive. This one, we have to turn all these on, the ones that we're using. Any of these ones that we're using, we have to turn on. Player marker material is okay. Player material, that has to change. There cannot be any. Once you see this right here, that is no good. Even though we're not using it, it doesn't matter. Please change it to, kind of that other material. So let's do that. So universal render pipeline and lit. Okay, and that should be all of them. There's not a lot of them, but that should be mostly all the ones that we have. Did you guys have the same success? Hopefully you did. So if you run it now, you should see that most of the things are converted. Even this one. That one doesn't look quite right. That's the bronze material on top of that thing. Let's make sure that that looks okay. So the bronze material, we just didn't turn these on. Okay, we got to turn the color maps for all those things, right? If we don't, then it won't look right. So let's try that again. And then we should be able to save this and put it up on GitHub because that is our conversion. There we go. And now everything works as it did before. Some of it may need a little bit of a patch in terms of our the way it works. Our concrete material, also, one thing to note is when we switched over to our new material, that's our base map. Ours is showing FFFFF. That's not a concrete material, and I know that you guys supplied that. So that would be 8076. So that's more of what the look and feel would be. Thank you for that. And I think that was Herman. Thank you, Herman, for that one. That's our concrete material. Otherwise, it won't look right. So save. And let's also convert to Android before we put it up on GitHub. So build settings. And I want to go to Android. And I want to go to player settings here for Android. And in Android, notice we use the linear color space and we use the auto graphics API. Please turn this auto graphics API off, uncheck it, and remove OpenGLES. We cannot use OpenGLES anymore. We need to use only Vulkan. Okay, so it must only support Vulkan if we're going to use the URP. If you try and use OpenGLES, not going to work. Okay, that's some stuff. This is obviously Lab 6, or that we've used before. IL2CPP, .NET Framework, all the same stuff that we had before is in place. One thing to also note when it comes to graphics and everything else, again, a linear color space is required, like we said before. We are not going to show things in portrait or portrait upside down. It's only going to be in landscape mode. And let us save these settings. And then we'll do a platform switch. Now this is where sometimes, warning, sometimes when we switch to a different platform, it breaks our code, just FYI. So let's try that, switch. And this should be the most of what I wanted to do today. Because without the URP, then we cannot, absolutely cannot make VFX graph work. Yes, Yaniv, and then Vincent.
I raised my hand earlier, sir.
Sorry about that. Okay, thank you. And
yeah, on my end, so the stuff that we imported from Blender all go under Autodesk Interactive, because there's one, because you go to URP and then the shader, URP, Autodesk Interactive, and then Autodesk Interactive.
That's the one.
The right track?
Yeah.
Okay.
Yeah. So for example, the gravel cobble, right, which was the if it's just a regular standard shader, it's universal, kind of universal render pipeline, and then I put lit, but you can also choose Autodesk Interactive, and then Autodesk Interactive. If you do that, you need to turn on the color map. Okay, that's one thing you need to do. Okay. If you don't turn on the color map, then that's a bad thing.
I see.
All right, so file, save project. And now what I want you to do is pull up, last thing, I know we're going to go a little long, but I want you to put up LD Player and test it out. Because without LD Player working, who cares what we did locally on Unity, right? If it doesn't work on LD Player, chances are it won't work on your phone. If it works on LD Player, it may work on your phone. Okay, and let's get rid of some of this old stuff. We don't need this. Clean it up. Okay, and now that LD Player is open and we've converted to our Android state, we can confirm that we have a device that's available. Let's refresh so we can see the device. Should see all your devices. And your device should come up here. If it doesn't come up, that's a bad thing. Please select your Samsung Galaxy A975N. All right, there it is. And then we'll do a build and run, and we'll push this into the builds folder. And inside the builds folder, I want to go and make another folder called Android. So we're also going to try it on WebGL. Save. How about lab 6 and then save? And away we go. So notice we're only rendering to Vulkan. Okay? Is that still a hand, Vince, or are we good to go?
Yeah. So my group converted over to URP pretty much back in like week 3.
Good.
And sometimes we get this like error that I lost it now, but it said something along the lines of like worker I just lost it, but we got like an error. I think it was like URP related, where it's like worker ID or something. I don't know. I just lost the error text. It was on my console just like 5 minutes, like just 30 seconds ago. I'll let you know if it comes back on. But that error's come up ever since we converted to URP.
Does it work still?
It still works. It's just like wondering if that's like a cause for concern or something.
No. The only time it's a cause for concern is if it stops you from deploying to your device, your actual device. So the way to test that, if there's still an error, is have an actual Android phone and put it in, kind of deploy your device, your app to your phone. And if it fails, that would be bad. Then you have to hunt down that error. And sometimes it's reconstructing your project. That's the problem. Or updating your project to another editor version. That also can fix the problem. That's when we talked about we're not going to update unless we actually have to. That's when we would have to. If let's say we all encountered the same error, but then we tried another version of the editor and it didn't, we would all upgrade. Okay, because that would make sense, right? But I'm not going to get you guys to upgrade because then we're going to have all these incompatibility issues between my code and your code, between your code and your partner's code. Forget it.
Right.
All right, and really this is all I wanted to do. As soon as we test this, we're done for today, and then we'll continue with VFX Graph on Thursday. Because we can't do VFX Graph unless we get this stuff done first. And I wanted to take away the controls so we can test it, quickly in Unity. And if we wanted to also test it inside of WebGL, we can do that too. WebGL is a funny beast when it comes to VFX, just FYI, right? So it doesn't quite work the same. And some things are not supported on without having with it working properly in WebGL. Just FYI. Okay, some stuff works, some stuff doesn't work, and that's where we are. That's the state of Unity as it is today. Questions so far from anybody that's with us right now? I know I lost a couple people, and that's okay. It is what it is. But we're just going to keep going. Yep, it's taking longer because it's trying to convert our textures and everything else over as well. So it's doing a bunch of conversions and other things. And again, the hope here is that we're going to make it work with LD Player, right? And that it works okay. And after this, we're done. Like I said. I know, it's crazy. Well, this is good. This is I post generate Gradle Android project callbacks. When I get to this point, I'm like hopeful that it's almost done. And does it fail? Let's see what happens inside of our LD player. All right, there we go. It says, and this is what I wanted to see. So it says, your device does not match the hardware requirements of this application. We're going to disable this warning, and we're going to click continue. And it says, your device doesn't disable this warning, and click continue. And then when we do, we're going to get this big purple screen. Okay. So, yeah, no. I mean, I'm not sure if you guys were able to make it work, but this is what I had before. So remember that we're trying to use the GPU, right? So this is the thing that's happening here, right? So you see how we get all these errors, right, for the universal render pipeline? And it's a ton of errors, right? So do you see these errors here? So why do you suppose we would get like all these crazy amounts of errors? So we can go back and we can see what it says. So desired shader compiler platform is not available in shader blob. All right, that's the first thing it says, right? It says, and remember we're doing with the LD player, right? I'm just, again, pointing this out for you so you get it, right? And let's go back to this and talk about this a little bit. So in our model, right, we're choosing a Samsung Galaxy, whatever it's going to be. And then in our game, settings, it says enable vertical sync and blah, 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 right? And notice it also says PUBG mode. It says 1080p applicable to GTX 750 Ti and up, right? As an example, and this is the 720p default resolution, right? But there is no, even in other settings, as an example, there is nothing inside of. Did you get errors, or did it work for you, Vince?
It worked on my end.
On
I
LD
don't
player?
have. I don't,
Awesome. That's great. So what did you do? Can you share your settings? Because I've always had hit and miss with this thing.
I feel like is it for LG player specifically, or because I didn't really change much of that. Other settings.
I don't think so either. I think that this is all the same, but maybe it's something that I changed inside of our scene. Did you change Vulkan or no?
Oh wait. My color gamut is at sRGB. No, I don't.
That
There must be
was.
something I've been missing because you did go through your player settings fast.
Sorry. It's here. See where it says graphic APIs Vulkan only, right? So if you chose, you can also add in OpenGLS2, right? OpenGLS3, right? You could do both. And if you choose Auto Graphics API, then it'll work. But warning, warning. If you did this, right, I have to be honest, right? The reason why this will work for us right now is because we're emulating, but it won't work for some phones. So I'm pointing this out, and this is where the issue is. I knew this before, right? So that's why I'm saying sometimes you get these weird things because they're following the Unity manual, right? Unity manual says don't use Auto Graphics API and uncheck this and remove OpenGLES and so on.
Right.
Recommendation is if you remove OpenGLES, yes, you will, right? So let's try this again, and let's see how it works now after I just use the Auto Graphics API, right? So we'll just do another build and run, and again we'll just build and run over this one, and it's going to take us pretty much the same amount of time. But at least this way we can test it, and it's an emulation. It's not perfect or anything like that, but you can see the difference. That's the idea. So when we do the Auto Graphics API, it should be working okay. Just like Vineet says. So I was concerned. I was like, you made it work? Wow, okay. What did I do wrong? Because I can't make it work. Right.
Yeah, it was interesting. So yeah, I'll probably get a messed up one. So
well, and so Vineet says Auto Graphics API can vouch for a model Samsung Galaxy S10 Plus. Yes, but does it work on an actual phone? Probably not.
yeah.
Right. That's the thing. Right. So. For actually the one thing that you'd want to test it on is like I said, an iPhone, iPhone 13, one of those kind of modern phones, and you're going to notice that for the most part it will be okay, right? So now a couple things to note, guys. Look at this. So we have the URP working. You can tell the color differences. We're using the new shaders, so that's something that's happening. Those are good. This works okay. And we have our on-screen controls working, and the map turns on and off. Map is kind of weird now for a couple of reasons. One, I truly believe that either this has to be made bigger or we need to adjust it than how we did it before. All right, so again, if I was to rush over here and jump, okay, and let's just save it way over here. So we'll press the save button. And again, you can check inside Unity that it actually did save inside of the logcat. See, it says game data saved. And then we stop this thing, run it again, and then we load it, then yeah, we're pretty good, right? So it kind of works the same way, and it also angles us in a different direction. If I was to look up here though, it wouldn't work, because remember, we're not saving the camera rotation in any way. So pretty cool. So this is where we want to get to, guys. Again, I wanted to point out the difference between one and the other. So hopefully you got that. That is the error that you're going to get. That weird error that basically errors out everything. And it's because of, just for you guys, for future reference, if you go to your player and you go here, right, to your auto graphics API, first of all, Gamma will never work. But even if you choose linear and auto graphics API, it will only work on the emulator because it's truly not using Vulkan, because it can't use Vulkan, because we don't have an actual GPU. Okay, and that's it for today. So let's, any questions before we go? We'll meet on Thursday and we'll start in with VFX Graph.
So we just can leave the build on auto graph.
I would say that for today. Yeah. For us, for our purposes, it's okay.
Okay.
Yeah, because I mean, realistically, it's just not going to work.
Okay.
Okay. Any questions before we go? All right, guys, I'm going to stop recording this on YouTube, and we'll see each other on Thursday. Thanks a lot. All right, take care.